All right, welcome Algebra 3 students. Welcome to your first lesson of the year. So I have a problem, a math problem up on the screen here, and you might be flipping out right now. You might be looking at this saying, holy cow, what is going on here? This is a math problem that looks very intimidating, and I'm here to tell you that it's really not. It's really fairly straightforward, not too difficult. But the intimidating thing about this math problem is the symbols involved. I'm sure this math problem has some symbols that you've never seen before. A lot of you are probably looking at this problem saying, hey, what is this E-looking thing here? What is this sideways 8? Now, a lot of you might know, well, that's the infinity symbol, but what does it mean in this context? And what am I supposed to do with this K equals 1? A lot of times with your more advanced level math courses, as you get into Algebra 3 and pre-calculus and calculus, a lot of times the intimidating thing is figuring out what do all these symbols mean. And in a lot of cases, if you can figure out what the symbols mean, I think you'll find that the math behind it isn't too challenging. All right, let's look at another example. Here's an example here. And by the way, by the end of this course, you'll be able to solve this very, very simply. All right, here's another example where you have these symbols that probably look foreign to you. We have this R with an arrow over it. We have this XI. The I has like a little cap on top of it. YJ, the J has a little like cap over top of it. You're probably looking at this saying, what in the world's going on? What do these symbols mean? Well, this is an example that right now I'm sure you're very intimidated looking at this. But once we've studied these symbols, I think you'll find the math behind it really isn't too terribly awful. So why did I start by showing you these problems? Well, the first lesson we're going to start with today in this class this year is the first unit is called notations. And the word notations really means symbols. We're going to study in this first unit some common symbols that are used in your more advanced math classes. And once you get familiar with these symbols, I think you'll find the math really isn't too intimidating. So we're going to learn a group of symbols today known as set notation. And I want to start you off with a little bit of a brain teaser. I think you'll be able to come up with the answer to this pretty easily. But I want you to do this. I want you to come up with in your mind, list every month in the calendar year that does not contain an R. Fix my grammar here. Now, clarify. I only want to use the English language. Okay, in the English language, January, February, March, etc. List me every month that does not contain an R. Now, don't use Spanish language or Russian language. Just in the English language, come up with every month containing an R. And here is the solution. Hopefully, this is what you were able to come up with. So what you did here is you just created a list. And lists are great things. You might have formatted your list a little differently depending upon how you wrote down the answer. In math, when we're trying to come up with a solution, there's kind of a formal way of writing your solution, and it's called a set. The way we write a set is really just a list, but every item in our list is separated by commas. And then we kind of enclose our list using braces. I'm going to put a brace on the left of this list, a brace on the right of this list, and now this list is officially called a set. One thing that's special about a set is that a set is meant to be complete. Okay, when you give a solution as a set, it's not just a partial solution. It's not just some of the answers. A set is considered to be the complete answer, and you're kind of formalizing the way that you write out this answer as a set. So at this time, go ahead and get out a piece of paper. There's going to be some vocabulary words I want you to write down on a piece of paper. You will be quizzed on this at the end of the video, so you'll want to take good notes as you go. And let's start with a formal definition of the word set. A set is a collection of well-defined, distinct objects enclosed in braces. And the objects of a set have a name as well. Those objects have a name. The objects are called the elements of that set. So an example of a set is what we wrote up here. Notice these months are very well defined. There's no confusion about what the months are, May, June, July, and August. And they're all distinct. That means that they're all different. You would never write the same month twice in a set. Okay, you would never write like May, June, June, July, August. They're all distinct and unique. You never see any repeats in a set. And then the braces you have here, the left brace and the right brace. So that's the definition of a set. All right, let's go to the next definition, an empty set. An empty set is actually a set that has no elements. It's completely blank. And an example of this would be, imagine if I said, make me a list of all the months that contain the letter Z in the English language. Well, that's empty. There's no months that have the letter Z. Now, the way we would write the empty set, there's two ways to write it. You can either write it as a pair of braces with nothing in the middle. This is one way to write an empty set. Or there's another way to write empty set. You actually draw a circle and put a slash through it. This is another way to write empty set. And the empty set basically means that we've come up with a problem, a scenario, that has no answers at all. And this is how we would write. If we ever come across a problem in this class that has no solution, this is how we can write the answer, either with the pair of braces with nothing between them, or the circle with the slash through it. These both mean empty set. All right, let's move to the next vocabulary word. The last two vocabulary words, finite set and infinite set. Let's put the definitions to both of these up here. So a finite set is a set that has a countable number of elements. The set comes to an end. The list comes to an end eventually. For example, let's say I came up with a set, list all the integers that are greater than 0 and less than 4. Well, that's a very small set. And I could write that set out. That set would be 1, 2, and 3. Those are the whole numbers or integers that are greater than 0 and less than 4. There's 3 answers, there's 3 elements in that set. Now, an infinite set is a set with an unlimited number of elements. For an example of this would be, what if I said list all of the integers or whole numbers greater than 0? And that infinite set would look like this. I'd start writing, I could write 1, 2, 3, 4. But if I had to list all of the numbers or whole numbers that are greater than 0, this list would continue forever. And what we do with a set like this, one way we can notate a set like this is for our last element that we're going to write, we can actually put a dot, dot, dot. And that's a way to show, hey, this list continues forever. Hopefully you can see the pattern now of what I'm writing. But the way we notate an infinite set is with a dot. Our last element written is a dot, 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 like this. So make sure you've taken good notes on these. You will be quizzed on this by the end of the video. Make sure you've taken good notes. And let's start looking at some examples before I give you your little quiz at the end of this video. So example number 1, write each set. And problem 1 says, write all of the whole numbers less than 3. Now, before we answer this first example, let's really clarify what are the whole numbers and how are whole numbers different from the natural numbers and the integers. So whole number implies that there will not be any fractions or decimals in this set of numbers. Whole numbers, I'm just going to make a list. The whole numbers include the number 0, and then they're really just the counting numbers that we're used to counting with. The whole numbers include the number 0 and then go upwards from there without any fractions or decimals. Now the difference between whole numbers and natural numbers is the same list, but it does not include the 0. Okay, 0 is not included in the word natural numbers, but it is in the word whole numbers. Now integers, when we use the word integers, it's actually just like whole numbers, except it includes negatives as well. So with integers, you actually have to do a dot, dot, dot at the beginning of your list. And we would include some negative numbers in that list. 0, we would also include some positive numbers, but then we would also end the list with a dot, dot, dot. The set of integers is an infinite set that it goes to the left forever, and it also goes to the right forever. So this would be the set of integers. Let me put the set notation on these. So with that in mind, let's answer this first example. Write the set of all the whole numbers that are less than 3. Now the word whole numbers implies we would include the number 0. And I guess the other big question, and so of course we'd also have the numbers 1 and 2. Now the other big question is, would we include the 3? The answer is that we would not. When you see this phrase, less than 3, that means that the 3 is not included. So this is I'm going to just make a little note here. This is a finite set. It contains only 3 elements. That is a complete list. It is a finite set. All right, let's go to number 2.
Quick announcement. Make sure.
Number 2, the second problem in this example says write the set of all integers less than 3. So here we have a similar thing where we're going to have the numbers 2 and 1 and 0, but integers also implies we can also use negative numbers. So this list would also include -1, -2, -3. And this list would go on forever. It is an infinite set. Here, though, the little ... would actually go at the beginning of the list to show that this list continues forever in the negative direction. This particular set is an example of an infinite set. It has an infinite number of elements. All right, and then my favorite problem in this example is number 3. Write a list of, write a set of all the odd numbers that are also even numbers. Well, if you think about this, that doesn't exist. So what are we going to write? We're going to write the empty set. This is empty. There is no solution to this problem. There's no number that can be odd and even at the same time. So I wrote my circle with a slash through it. Let me make that a little prettier. That looks a little ugly. The circle with the slash through it. And that's actually my answer. My answer is that there is no answer. Okay? My solution set is the empty set. There is no solution to that problem. Now in our last example, example number 2, we're going to kind of go backwards with this example. In this example, we're given a set. And essentially, we're asked to kind of write a definition of that set. And we're going to use something called set builder notation. Okay. So if you're ever asked to write something using set builder notation, the key is this. Set builder notation will always start with a symbol that looks like this. Okay. You'll have a left brace. You'll have a variable that you get to choose, and then you'll have a long vertical line like this. Now there's a meaning behind this. When you ever see this symbol, this literally translates to all values of x such that. Okay, when you see this vertical line here, that actually means such that. So when you write a set using set builder notation, here's how you're always going to start. You can use whatever variable you want. I used x, but this translates to all values of x such that. So let's look at the set we're given. We're given the numbers 2, 4, 6, and 8. There's a lot of different ways that we could write this with set builder notation, but I'm going to start with all values of x such that x is, here's the definition I'm going to come up with. X is an even whole number. Well, actually, I can just say even number. Even implies that it's a whole number. So we're just going to say x is an even number between 2 and 8. And then I want to add one word here. You know, the word between is a little tricky. When you use the word between 2 and 8, there's always the debate about, well, does that include the 2? Does that include the 8? And technically, the word between would actually exclude the 2 and the 8. So I'm going to add one more key word here. I'm going to add the word inclusive. And that means that the 2 and the 8 are included. So if you think about what's every even number between 2 and 8, and we want to include the 2 and the 8, this is the set that we've come up with. And so here's a way, set builder notation is a way that you can write a set using your language instead of just making a list of words. You can write out a set using a description using your language.